we're going to learn more about quadratic equations in this lesson. So when you're solving quadratic equation, it's important to choose the method that's going to be most appropriate for the problem that you're given. So there are three different methods that we can use. There's the square root property, there's factoring, and there's also the quadratic formula. These are kind of the questions you need to ask yourself to determine which method to use. I know we've also talked about completing the square. However, we are usually not going to use the complete the square to solve a quadratic equation, but it is important to know how to use completing the square because, one, that's how we get our quadratic formula. That's what it's derived from. And then also, that technique is going to make other things easier as well when we're looking at quadratic functions. And then again, when we get into higher levels of algebra, we're going to use that technique of completing the square again. So it is important to know how to use it. So the very first thing you want to do when you're solving a quadratic equation is to put it into the general form ax squared plus bx plus c equals 0. Once you do that, these are the questions you need to ask yourself. If your b value is 0, in other words, there is no x term, it's just ax squared plus c equals 0, then go ahead and apply the square root property, which means you solve for x by getting everything over to one side and then square root both sides. Now, if the polynomial factors easily, then use the factoring method. And then otherwise, if the square root method or the factoring method doesn't come easily, then go ahead and use the quadratic formula. You can always use the quadratic formula to solve a quadratic equation. Just a reminder, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So there is a particular part of a quadratic equation called the discriminant. Now, the discriminant is going to be the radicand in the quadratic formula. Remember, the radicand is what's underneath the square root symbol. So we square root the b squared minus 4ac. So the b squared minus 4ac is what we call the discriminant. The discriminant is important because it's going to tell you how many solutions you have and the type of solutions you're going to have for the equation. So we use a capital D to stand for discriminant, and it's equal to b squared minus 4ac. So again, the discriminant tells us the number and type of solutions for our equation. So if your discriminant is greater than 0 and your discriminant is a perfect square, which means you can take the square root of it perfectly, then you're going to have two rational solutions. If your discriminant is greater than 0, but it's not a perfect square, you're going to have two solutions still, but they're going to be irrational. If your discriminant is equal to 0, you're going to have one rational solution. If your discriminant is less than 0, which means it's negative, then you will have no real solutions. So let's do some examples. Let's say I have x squared plus 5x minus 7 equals 0, and I want to find the discriminant. So first I'll identify my a, b, and c values. A is 1, b is 5, and c is actually negative 7. And then I will find the discriminant. So the discriminant is b squared minus 4ac. So I'll replace b with 5, a with 1, c with negative 7. So I have 5 squared minus 4 times 1 times negative 7. I will go ahead and do 5 squared, which is 25, and I'll do 4 times 1 times negative 7, which is negative 28. When I do 25 minus negative 28, it becomes 25 plus 28, which is 53. So 53 is not a perfect square, but it is greater than 0, which means I'm going to have two solutions, but they will be irrational solutions. Let's try another example of finding discriminant. Let's say I have the equation x squared equals 156 minus x. So the first thing I have to do is to get everything over to one side and set equal to 0. So I'll subtract 156 from both sides, and then I will add x to both sides. That will leave me 0 on the right, and it's going to leave me x squared plus x minus 156 on the left. Now I can identify my a, b, and c values. A is 1, b is 1, and c is negative 156. And then I'll find my discriminant, which is b squared minus 4ac. So b is 1, a is 1, and c is negative 156. So when I plug those values in, I get 1 squared minus 4 times 1 times negative 156, which simplifies to 625. So 625 is a perfect square, which means that there's going to be two solutions, and they will be rational. All right, another discriminant example. We have 3x squared plus 5x equals negative 9. I need to move that negative 9 over, so I'll add 9 to both sides. Now it's set equal to 0, which means I can identify my a, b, and c values. A is 3, b is 5, and c is 9. Then I'll use my discriminant formula, which is b squared minus 4ac. I'm going to plug in 5 for b, 3 for a, and 9 for c. And I get 5 squared minus 4 times 3 times 9, which evaluates to negative 83. So since my discriminant is negative, that means there are no real solutions. Alright, something interesting that you can also do with quadratic equations. If you know what your solutions are, then you can also know what the original equations are. And the reason we know this is using the zero product property, which says that if a times b is equal to 0, that means a is equal to 0 or b is equal to 0. So, if we know our solutions are x equals 5 and x equals negative 7, then that must have meant that x minus 5 was 0 and x plus 7 equals 0. And so, since we know that x minus 7 equals 0 and x plus 7 equals 0, those are our two factors. Our two factors are x minus 5 and x plus 7. Now that we know that our two factors are x minus 5 and x plus 7, we can multiply those out, and we can multiply them out using the FOIL method or the box method, and we end up with x squared plus 2x minus 35 equals 0. So we end up with our original equation. Let's do another one like that. Let's say we know our solutions are 2/3 and negative 1/4. The first thing that we want to do is kill our fractions. So we'll multiply 3 to both sides to get 3x equals 2. And then on the other solution, we're going to multiply both sides by 4. So we get 4x equals negative 1. Now we want them to set to 0, so we'll subtract 2 from the left-hand side, or the left equation. So we get 3x minus 2 equals 0. And then for the right equation, we're going to add 1 to both sides. So now we have 4x plus 1 equals 0. Now that we know what the two things that are equal to 0, we know what our two factors are. Our factors are 3x minus 2 and 4x plus 1. Now we can multiply those out using the FOIL method or the box method. And our solution ends up being 12x squared minus 5x minus 2 equals 0. That's the original equation.